Okay, just to recap, we have the rules of exponents. The first one we're going to talk about is the multiplication rule, which sometimes you see it as a to the n times a to the m. You know, we're just using arbitrary variables that represent numbers. And arbitrary means I just picked these. A to the n times a to the m equals a to the n plus m. So that's the rule. What does it mean? It means when bases are the same, we can add exponents. Okay, how to remember. Multiplication is repeated addition. So that's one way to remember. And here's an example of what we're talking about. For example, 2 to the third power times 2 to the sixth power. The 2 is the base, and the exponents are 3 and 6. So remember, when bases are the same and you're multiplying, add the exponents. Well, here we're going to show that 2 to the third times 2 to the sixth, they're being multiplied and bases are the same. That would equal 2 to the 3 plus 6, which is 9. And then we can justify that right there by saying 2 to the third is 2, all multiplied, times 2 to the 6, which is 6 twos, 2. How many 2's do we have? A whole lot. So we simplify that by writing it as 2 to the ninth power. We added up all those 2's and put it to the ninth power. A lot of times kids, when they see this, 2 to the third times 2 to the sixth, they will think it is 2 to the 2 times 9, or 2 to the third, plus 6 is 2 to the ninth times 2. They add another 2. No. It is just 2 to the ninth. 2 to the 3 plus 6 is 2 to the ninth. All right, here's another example with a negative. Oh no. 2 to the negative third power times 2 to the sixth. Well, we do the same thing. When bases are the same and we are multiplying, we add our integer exponents. Negative 3 plus 6. We have 3 negatives, 6 positives. You can also reverse those as 2 to the 6 minus 3. So negative 3 plus 6 is 3. 2 to the third times 2 to the 6, 2 to the negative third times 2 to the 6 is multiplication. And when bases are the same, you add the exponents. And when you add the exponents, you get 2 to the third. Now, we're going to justify this. 2 to the negative 3. Anything to a negative power is a very, very small number. So that is equivalent to 1 over, or 1 divided by 2 to the third, which equals 1 over 2 times 2 times 2. 2 to the 6 is a very large number, so it's 2 times 2 times 2 times 2 times 2 times 2. Now, how that looks is the big number, which is the 2 to the 6th, would go on top. 2. 2 to the negative 3 is our very small number. Remember, it's 1 over 2 to the third. So that goes on the bottom, the small number. 2 to the negative 3 is 1 over 2. All right, and then we can cancel out all the 2's that are 2 over 2, because that equals 1. And anything times 1 is itself. So we cancel those out. I can cancel 3 out because there's 3 on the bottom, 6 on the top. And the 3 that are left over on the top becomes 2 to the third power. So when bases are the same and you're multiplying, you can add your integer exponents. Or you can think about it in terms of the negative exponent is on the bottom and the positive exponent is on the top. And you can cancel them out if you are unsure that you remembered your integer rules, because it's been a little bit of time. Okay, last example. 2 to the third times 2 to the sixth times 2 to the negative 7. Well, first we have to look. Yes, all bases are the same, so we can add our exponents. And you can do that in chunks. We know that 2 to the third times 2 to the sixth is 2 to the 3 plus 6. When bases are the same, you multiply and you add the exponents, which was 2 to the 9. And we knew that from our example up here. All right, so we got 2 to the 9th times 2 to the negative 7. All right, when bases are the same and you're multiplying, you can add your exponents. So 9 plus negative 7, or 9 minus 7, is 2. So 2 to the second power, which is 4. What we want to do is justify this. We know that 2 to the 3 times 2 to the 6 is 2 to the 9. Very big number, so it's on top. We will have 9 2's being multiplied on top. And 2 to the negative 7 is a very small number, so we'll have 7 2's on the bottom. Cancel out the 2 over 2, and it is leaving us with 2 2's on top, which is 2 times 2, which is 4. All right, so when bases are the same and you're multiplying, you what the exponents? Add those exponents when bases are the same. And what we're talking about as the base is the number or variable that is being multiplied over and over again determined by the exponent. So when bases are the same and you're multiplying, you add exponents. All right, guys, thanks.